Okay, let's unpack this. For the past couple of years, when most people talk about LLMs, large language models, they're probably thinking about, a text box. You type something in, you get something back.
Right, it's reactive. Kind of passive, really.
Exactly. But the research we've been digging into, it really suggests we're hitting this massive inflection point. We're moving from those passive assistants to systems that can genuinely, well, think and act for themselves.
That's the core of it, absolutely.
Mhm.
Our mission today is to do a deep dive into this whole AI agent revolution. We're going way beyond the static machine learning models or, the simple chatbots that just follow a script.
Uh-huh.
We're talking about really quite sophisticated systems. They're goal-oriented, they can autonomously think, execute actions, and maybe most importantly, reflect on what happened. Did it work? Should I change course?
That idea that the autonomous reflective action, that feels like the huge difference. It's like the difference between a calculator just giving you an answer and having a strategist who can adapt.
Precisely.
And the sources we looked at, wow, they're incredibly rich. They cover how these agents are actually being put to work right now in some really diverse, high-stakes
Yeah,
fields.
like cybersecurity ops centers you
Yeah.
mentioned.
And complex IT operations, specifically site reliability engineering, SRE, even things like sales and lead generation, and maybe surprisingly really complex creative stuff like writing novels or designing narratives.
It's a fundamental shift.
Hey,
We're moving away from those reactive assistants that just follow a fixed flow.
right.
And we're moving towards something much more dynamic, intelligence that adapts itself. Think of it maybe like this. The old system, it's like following a recipe printed on a card. Step one, step two.
Very rigid.
Very rigid. The new agent is more like hiring a really talented chef, someone who can, improvise perfectly if they suddenly realize the oven's running hot or they're missing an ingredient. They adapt.
Okay, so to really get why this shift is so powerful, let's start with the old way. What were the limitations these new agents are meant to overcome? And cybersecurity seems like a great place to start because it's often built on these really rigid defenses, right? It shows that brittleness.
It really does. Traditional cybersecurity, it's inherently brittle. It relies so heavily on static rules, signature-based detection, spotting known bad stuff.
Yeah.
A typical incident response workflow, it's a fixed sequence.
Yeah.
An alarm pops up.
Okay.
Someone collects data, they check a specific indicator from a list, and then an analyst follows a playbook that someone had to manually update.
Okay, so what happens then if an attacker does something slightly different, something not in the playbook?
Well, the whole process just grinds to a halt.
Sure.
If the attacker tweaks one little parameter, or if it's a brand new type of vulnerability, a 0-day,
Mm-hmm.
that fixed flow just breaks. It can't cope. And, traditional machine learning models, they often have similar problems. They're usually quite narrow.
Right, trained for one specific thing.
Exactly. Like just classifying known malware. They look for patterns they've already been shown. If the pattern changes even slightly, the model's basically useless until a human comes along and retrains it.
So the old systems are brittle, fixed. How does the AI agent manage to break out of that? How does it adapt? What's the sort of core definition?
Well, an AI agent uses the LLM, the large language model, but not just to generate text.
Mhm.
It uses it as its central reasoning engine.
Okay.
Its main job is to understand a complex goal and then autonomously decide on and execute actions out there in the real world or its digital environment. It's interactive. It's a loop, not just a one-off response.
And making those decisions, that must require more than just understanding language, right? It needs specific capabilities to be autonomous.
Absolutely. First, it needs really comprehensive data intake. It has to pull in the usual structured logs and telemetry, sure, but also handle huge amounts of unstructured text. Security reports, detailed alarm descriptions, even the subtle language used in a phishing email.
Got it.
Second, it needs contextual interpretation. The ability to see beyond just keywords and understand the intent. Is this alert actually malicious? Or is it just, I don't know, a sysadmin doing some routine work clumsily?
And then it has to actually do something, manipulate its environment.
Right, that's tool utilization. The agent has to intelligently decide for itself which external tool it needs to run next. Should it query a threat intel database? Should it check the CRM? Should it run a script on a server?
And that decision is dynamic.
Completely dynamic,
Yeah.
based on its current understanding of the goal and the situation, which leads straight to active interaction, actually calling that API, running that script, and then using the result to figure out the next step. It adapts the workflow as it goes, just like a really experienced human expert would.
This sounds like that agentic stack idea we read about, a really fundamental shift in architecture. moving away from the standard LLM, just doing one thing, input, output, done, to this continuous cycle.
That cycle is the key to autonomy, that iterative loop. It's what gives the agent persistence intelligence over time.
Let's break down that cycle. It's 4 steps, right? Perceive, think, act, reflect.
That's the one. It kicks off with perceive. The agent takes in the current situation, any new data streaming in from its sensors or tools.
Okay.
Next, it moves to think reason. This is where it formulates a plan, maybe a hypothesis, or develops an internal chain of thought based on what it perceived. Basically, figuring out the path to its goal.
Then it acts on that plan.
Third step, act. It executes the action it just planned, usually by calling one of its available tools, querying something, sending something, running something.
And the last step, this feels like the really crucial bit that makes it different from a standard LLM just spitting out text.
It absolutely is self-reflection. After it acts, the agent reviews the outcome. It asks itself, essentially, did using tool X get me closer to my goal? Or was that output useless? Or maybe even misleading? Based on that critical self-assessment, it updates its internal strategy and starts the loop again. Perceive the new situation, think, act. That self-critique is how the system learns and stays on track during long, complex tasks.
Okay, so for the LLM brain to actually run that complex loop, it needs some extra bits. The sources mentioned 3 essential architectural components that make it truly autonomous.
Yeah, you can think of them as the agent's arms and legs, its memory, and its connection to current reality.
Yeah.
Number 1, tools. These are the actual functions the agent can perform, its reach into the world. If an agent can't, say, check a CRM or query data in an X3 bucket or run a simple script, it's not really autonomous, it's just planning.
Right, it can't do anything. And the second part is memory, so it doesn't have amnesia every time the loop restarts.
Exactly. Memory is crucial, and it's usually tiered. You have short-term memory, often called the scratch pad or just the context window, that holds immediate stuff like the last few steps of the task or a short conversation history.
Okay.
But for persistent strategic knowledge, like maybe records of all past successful incident responses or detailed character backstories for that novel-writing agent, you need long-term memory. And that's typically implemented using a vector database.
Right, vector databases. You hear that term a lot. Why specifically a vector database for long-term memory? What's the advantage over just a regular database?
Good question. A standard relational database finds things based on keywords or exact matches. A vector database works differently. It enables semantic retrieval,
Meaning
meaning the agent can store the conceptual meaning of past information. So if it dealt with a tricky incident last month, and today it sees a new problem that's conceptually similar, even if the exact words or log formats are totally different, it can retrieve that relevant history. It finds related ideas, not just identical text. This is huge for overcoming the limitations of context windows and preventing the agent from forgetting crucial details over time.
Okay, that makes sense. And the third piece is knowledge, often using RAG retrieval augmented generation.
Our RAG is vital, because even though an LLM is great at reasoning, its training data is frozen in time. It gets outdated fast.
Sure.
Our RAG lets the agent connect to external, live, up-to-date data sources. Think current stock prices, the very latest cybersecurity vulnerability reports, or live data from a CRM system. It pulls in this fresh information right when it's needed for a decision. It stops the agent from making critical choices based on old, possibly wrong, training data.
That technical foundation is really interesting. But let's swing back to the sort of operational need. The sources really hammered home that this move to agents isn't just a cool tech thing. It's becoming strategically necessary, especially now because of this, dual crisis hitting security operations centers, or SOCs.
Oh, absolutely. This dual challenge is really pushing SOCs to a breaking point.
Huh.
The first part is just the overwhelming data flood.
Yeah.
Every single piece of software, every device, every cloud service is spewing out logs, telemetry, security alerts. The volume is just exploding. It's becoming almost impossible for human analysts to actually spot the real threats buried in all that noise. They're drowning.
It's the needle in the haystack problem, but the haystack is growing exponentially and on fire.
Tuckles. That's a good way to put it. And the second challenge, it's maybe even more fundamental.
The people problem.
The catastrophic talent shortage. There's a massive, chronic lack of skilled, experienced cybersecurity experts. The research we saw estimated something like 500,000 open cyber jobs just in the U.S. You simply cannot staff these old-style, human-heavy security operations when the talent pool is that shallow and the data flood keeps rising.
So the agent becomes the strategic way to bridge that gap. It's not about replacing people entirely, but about augmenting them. making the experts we do have massively more effective.
Precisely. It lets those overwhelmed human experts shift their focus. Instead of spending hours manually correlating logs or hunting for basic indicators, they can focus on the really high-level stuff. Strategic decisions, validating the agent's findings on complex issues, proactive threat hunting.
Okay.
These agents, they're designed to think and act autonomously, but within clearly defined guardrails. They maximize the reach and efficiency of the human expert. And the operational benefits are, well, they're pretty revolutionary.
Speed has to be number one.
Speed is the killer app here. When an agent takes over the initial triage and investigation, the time needed can plummet. We're talking potentially going from hours, which is pretty standard for a human digging through logs, down to minutes.
Wow.
And importantly, this speed doesn't necessarily mean less accuracy. The agent can be incredibly methodical and check everything systematically.
Now, what about the human factor? Burnout, fatigue, that affects performance.
Agents address resilience. They don't get stressed, they don't burn out, they don't need coffee breaks or sleep. This cuts down dramatically on the variability and potential for errors that come from human exhaustion, which is a huge hidden factor in many SOC failures. Plus, their adaptability. They can handle weird, disguised, novel attacks much better than rigid scripts. They interpret the context, they correlate clues from different systems that a simple signature rule would completely miss.
Okay, but I have to push back a bit here. This adaptability sounds great, but if the agent is doing all the basic correlation and root cause analysis in minutes, aren't we kind of de-skilling the next generation of analysts? They won't learn those fundamental log hunting skills if the machine does it all.
That is a really critical point.
Yeah.
And it comes down to how you implement these agents. The goal has to be augmentation, not replacement of the learning process itself.
So how do you do that?
The key is that explainability feature we talked about. A junior analyst shouldn't just get an answer spat out by the agent. They need to see the agent's full chain of thought. Why did it reach that conclusion? What was the evidence?
Ah, okay. So they learn by reviewing the agent's reasoning.
Exactly. They learn from why the agent made that diagnosis. This frees them up to focus on learning about the more complex, nuanced threats the agent might not have seen before, rather than spending years just mastering the tedious task of searching through endless logs.
That makes a lot of sense. Okay, let's make this more concrete. What are the specific jobs agents are doing in SOCs right now, according to the research?
Yeah, 4 key areas really stand out. First, threat detection and triage. This is about managing that initial flood of alerts. Agents use semantic analysis, understanding the language, to look at the raw event data, the log lines, the alert descriptions. They figure out if the story told by the data points towards something malicious. And crucially, they do essential noise reduction. An agent might see, say, 50 separate firewall alerts firing off in quick succession from one source to many destinations.
Right.
Instead of creating 50 tickets for a human to sift through, the agent groups them all intelligently and says, hey, this looks like a single coordinated port scan attempt. That's a massive time saver right there.
Huge. Okay, what about once an incident is suspected or a big vulnerability drops?
That's the second area, incident response. When a critical security advisory comes out or a new 0-day is announced, the first questions are always, are we affected? And how bad is it?
And that usually takes hours of manual checking.
Hours, sometimes days. Agents can automate a lot of this. They use RGA and the reasoning loop to figure out the likely root cause or exposure. They cross-reference the vulnerability info with internal asset lists, search knowledge bases, basically replacing that slow manual log digging and research.
Okay. Third area. Phishing seems like an obvious one. How do they improve on, standard email filters?
Yeah, phishing is persistent. Traditional filters are often pretty basic. They rely on static stuff like blacklisting a known bad URL or checking if the sender address is on a block list.
Easy to get around.
Too easy. AI agents use much more advanced semantic analysis. They look for the subtle tricks, the social engineering tactics. Is the language trying to create fake urgency or fear? Does the writing style suddenly seem off compared to previous emails from this supposed sender?
Ah, so it's looking at the nuance of the deception.
Exactly. Things static filters just can't catch. This makes agent-based detection significantly harder for attackers to bypass.
It's like having a super vigilant junior analyst read every single email. Okay, and the fourth use case involved analyzing code itself.
Right, malware analysis. An LLM can act as a sort of junior reverse engineer. An analyst can feed it a suspicious code snippet.
Okay.
The LLM can then explain complex parts of the code in plain English. It can point out what the code is trying to do, identify risky API calls it's making, or suspicious system functions it wants to access. This can really speed up an analyst's understanding when they're faced with a totally new piece of malware.
This all builds towards this like ideal augmented workflow, doesn't it? The research laid out an 8-step process for how an agent could optimize analysis in a modern SOC.
Yeah, it's a logical flow from just raw data to an actionable output. It starts with the agent handling the collect step gathering data from all the different security tools, then enriches adding context from real-time threat intelligence feeds.
Okay, data in, context added, then the thinking starts.
Exactly. Then comes the cognitive heavy lifting. Correlate finding connections between events across different systems, maybe linking an identity log alert with some network activity, and predict, based on past attacks, what might the attacker try next.
Got it. Once the thinking's done, it moves to output.
Right. The agent then does prioritize, or triage, bubbling up the most critical threats so the human analyst knows where to focus first. Then it does reference, maybe mapping the observed activity to a framework like UMIRE, ATT, and CK to give it standardized context.
That's super useful for reporting.
Absolutely. Then it generates a recommend action suggesting a specific safe response. And finally, the agent handles the document step, automatically creating the incident ticket, writing up the summary, all that tedious paperwork.
So the agent basically handles all the time-consuming investigation and documentation, leaving the human with the final crucial decision on the recommended action.
That's the ideal, yeah. Augmenting the human, not replacing their judgment.
Okay, so agents working on structured stuff like logs, that makes sense. But what happens when you apply this same agentic structure to something really subjective, really creative, like writing a novel or designing a complex game narrative? The research was pretty clear that just using one big LLM for tasks like that, well, it doesn't really work.
No, it really doesn't. Writing a coherent, long story requires things like, keeping track of plot points over hundreds of pages, maintaining a consistent style, having a sense of pacing, knowing when to circle back to earlier ideas.
Hmm.
Single LLMs, even the massive ones with huge context windows, have these systemic weaknesses that mess up complex storytelling.
Let's break those down. The first one is basically a memory issue, right?
Yeah, context window overflow.
Yeah.
Even if an LM can technically read a huge amount of text, if you ask it to write a 100,000-word novel, well, by the time it gets to chapter 20, the specific motivation you gave a character back in chapter 2, or a crucial clue you planted early on,
Yeah.
it just gets lost in the noise. The model effectively forgets, or at least loses focus on, those earlier details.
Okay, so it loses track of the plot. The second failure isn't about facts, but about feel, consistency.
Exactly.
Yeah.
That's style drift. Or sometimes called regression to the default voice. Let's say you prompt an LLM really well to write in a very specific style, like hard-boiled detective noir, or maybe 19th century Gothic horror.
Uh-huh.
It might start out great, but over the course of thousands and thousands of words, it almost inevitably starts to drift back towards its generic, average training voice. Maintaining that specific stylistic flavor over a really long piece is something single models just seem to struggle with.
And the third failure gets right back to that crucial loop we talked about earlier, the missing self-check.
Precisely. The fundamental lack of a self-critique loop. A standard LLM is built to be fluent, to predict the next most likely word. It doesn't naturally pause and ask itself strategic questions like, is the pacing dragging in this section? Or did I properly pay off that foreshadowing I set up 5 chapters ago? Or is this character suddenly acting completely out of character? Without a built-in mechanism for that kind of critical reflection, it just keeps churning out words, and eventually the story's coherence can just fall apart.
So the answer isn't just a bigger LLM. The sources suggest the solution is a specialized multi-agent pipeline, like building an orchestra instead of relying on one musician trying to play every instrument.
That's a perfect analogy. It's about specialization to handle complexity. Instead of one model failing at 3 different cognitive tasks, you create a team of specialized agents, each designed to do one part of the job really well and have them collaborate.
Okay, so what roles do you need in this narrative design orchestra?
Well, it usually starts with a narrative planner agent. Its job is pure high-level strategy. You give it the basic prompt, space opera meets film noir or whatever, and it outputs a detailed structure, a beat sheet, basically outlining the key scenes, plot points, goals, conflicts.
Okay, the blueprint. Then you need someone to handle the memory problem.
Right. That's where the Character Forge agent comes in. It generates really detailed character biographies, their histories, motivations, quirks, relationships. And critically, it stores all this rich detail in that vector database we mentioned, the long-term memory.
Ah, so the main writing agent doesn't have to keep it all in its head.
Exactly. The agent actually writing the scene can then semantically query the database just for the character details relevant to that specific moment. It pulls in only what it needs when it needs it. This directly solves the context window overflow problem.
Smart. And then for the style drift problem you have.
A dedicated voice style agent. Its job is to ensure consistency. It takes the raw text generated by the writing agent and applies the target style, maybe based on examples you fed it, ensuring the tone, vocabulary, and rhythm stay consistent across the entire manuscript, no matter how long it gets.
Okay. And finally, the missing piece, the self-correction mechanism.
That's the critic agent. This is absolutely vital. It forms that self-reflection loop, but it's separate from the agent doing the creative generation. Its only job is to assess the output.
What does it assess?
Things like pacing, tone, whether the scene adheres to the plan from the beat sheet, character consistency, plot coherence. Then it generates concrete, specific change requests. Things like, the scene feels too slow, or character X wouldn't say this, or need to foreshadow the upcoming betrayal more clearly here.
And those requests feed back to the other agents.
Exactly. They feed back into the loop for the next iteration. So by breaking down the complex task planning, detailed memory, stylistic consistency, and critical review into specialized agent roles, you overcome the limitations that a single LLM would face.
Okay, that idea of using specialized agents to tackle massive complexity, it maps really well onto IT operations too, doesn't it? Especially for site reliability engineers, SREs. But here, the big challenge isn't, forgetting plot points from Chapter 2. It's about operational latency, especially when things go wrong under pressure.
Oh, absolutely. And the pressure often comes
Yeah.
down to cost. One of the sources had this fascinating and frankly slightly terrifying statistic about the human side of things. Sleep inertia.
Sleep inertia,
Yeah. Basically, if an SRE gets paged in the middle of the night for a critical outage,
which happens all the time.
all the time, the average time it takes for their brain to recover from sleep to being fully alert, sharp, and ready for complex problem solving is around 22 minutes.
22 minutes? That's an eternity during a major outage.
It's huge. And it's not just lost time. It's 22 minutes where a likely exhausted expert is just staring at screens, trying to get their bearings, figure out what's going on, while potentially millions of dollars are being lost per minute. The agent is designed to bridge that critical cognitive gap, like, instantly.
So the obvious, but apparently wrong, temptation is just to throw all the data at the problem, right? The brute force approach.
That's the big mistake people made early on, yeah. Just taking the entire massive fire hose of telemetry data, all the metrics, events, logs, traces, the whole MELT acronym, and trying to feed it directly into an LLM.
Why is that bad? Seems logical.
Because the volume is insane. A moderately complex system, like a microservices mesh, can generate petabytes of log data every single day. Trying to feed all of that into an LLM just completely overwhelms it.
And when you overwhelm the model with too much noise, too much irrelevant data, what happens? It's reliability tanks.
Exactly. The risk of hallucinations skyrockets. The model starts making connections based on statistical weirdness rather than actual cause and effect. It might see, I don't know, a temporary spike in cache usage happening around the same time as an unrelated configuration change and confidently invent this whole plausible sounding but completely imaginary story about how one caused the other and led to the outage. Brute forcing the data just leads to unreliable, untrustworthy analysis.
Okay, so the smart approach has to be more targeted. The sources talked about context curation and topology-aware correlation. What does that mean in practice?
It's about being selective, like a good detective. Think about it. If your car suddenly won't start, you don't immediately check the tire pressure, right?
No, you check the battery, maybe the fuel.
Exactly. You follow the chain of dependencies. The agent needs to do the same thing. And it can by using the real-time dependency graph. Most modern observability platforms maintain this map, showing exactly how all the services, databases, caches, load balancers, everything are connected to each other.
So the agent uses this map to focus its investigation. It doesn't even look at data from unrelated parts of the system.
Precisely. That's the key. Let's say the payment processing service starts throwing errors. The agent consults the dependency graph and immediately narrows its focus. It only pulls telemetry data from components that are topologically connected to the specific database instances that service relies on, the message queue it talks to, maybe the deployment history for those specific microservices, the relevant authentication service logs.
And it ignores everything else.
It ignores everything else, even if it's running on the same server cluster. All the unrelated microservices are just noise in this context. This drastic reduction in data volume, the context curation, is what makes the agent's analysis fast and reliable.
That makes perfect sense. Okay, so let's walk through the workflow. How does the agent actually support the SRE, especially during that critical 22-minute wake-up window?
Well, the agent can be running continuously in the background, constantly looking for anomalies.
Yeah.
When something pops up, say, web service latency starts spiking, the agent immediately starts forming hypotheses. Is it the network? Is it a bad code deployment? Is it the downstream database getting overloaded?
And how does it test those ideas without a human guiding it?
It uses its tools systematically to request specific, curated data to either validate or disprove each hypothesis. So if the top hypothesis is database overload,
Uh-huh.
the agent will automatically pull the latest database performance metrics and relevant logs from just that database.
Mm-hmm.
If those logs show, say, a recent schema change happened right before the errors started,
Ah.
the hypothesis instantly refines to problem likely caused by recent database configuration error. The agent might then automatically check the deployment logs for that specific database service to confirm who made the change and when. It follows the evidence trail.
So it builds up this clear step-by-step investigation log, like a detective's notebook.
And that traceability is absolutely vital for building human trust. The agent has to expose its entire chain of thought. It needs to show why it ruled out the network issue and zeroed in on the database config change. This is that explainability factor again. It lets the SRE quickly look over the agent's reasoning and go, okay, yeah, that makes sense. Or, maybe check this other thing too.
Got it. And then the final piece is moving from finding the problem to actually fixing it. Remediation.
Right. The agent can do a lot of the prep work here. First, it can generate a detailed step-by-step resolution plan, basically, a runbook tailored to this specific incident.
Okay.
Second, it can often transform that runbook into actual actionable scripts, like
Yeah.
generating the precise bash commands or the Ansible playbook needed to, say, roll back that faulty database change, including all the right parameters and syntax. It basically puts the fix on a silver platter for the human. And third, the agent can handle the boring part. Automated documentation. It can automatically write up the post-incident review, summarize what happened, what the root cause was, what steps were taken to fix it. Saves the SRE a ton of time on paperwork.
So the whole package significantly cuts down that mean time to repair, the MTTR, by having the agent do the heavy lifting during that critical initial period, effectively beating the sleep inertia problem through smart cooperative automation.
That's the goal, yeah. Faster, more reliable incident response.
Okay, let's pivot completely now. Away from technical crises and towards the business side specifically, lead generation and development. The business case here seems less about preventing catastrophe and more about just pure, relentless efficiency, right? Dealing with huge amounts of data, complex decisions about who to contact when, it seems right for agent automation.
Absolutely. Lead gen involves sifting through massive volumes of information, potential client signals, market changes, competitor moves, prioritizing who to reach out to, when, and with what message. It's complex, often multivariate, and traditionally involves a lot of time-consuming manual work by sales teams.
Checking CRMs, scanning news feeds, writing emails.
Exactly. Agents are really well suited to streamline this. The goal is continuous, autonomous monitoring, identification, and prioritization of the best leads based on criteria that can be constantly updated. Instead of a human spending, say, 2 hours every morning compiling reports and lists, the agent can be doing aspects of that job every single minute, 24/7.
So for the folks listening who might be thinking, okay, I want to build one of these, the developers, the architects, the research actually laid out a pretty clear 6-step practical guide for developing a working agent system. Let's walk through that process.
Sure. Step one is pretty fundamental. Define the use case. You've got to be really clear up front about what you want the agent to do. Is it mostly going to be working autonomously in the background, maybe monitoring competitor websites for price changes or scanning industry news for trigger events?
Or is it more interactive?
Right. Or is it going to be interacting directly with the user through some kind of interface, like a sophisticated chatbot helping qualify sales leads or answering complex customer questions? The requirements are quite different.
Okay, define the job. Step 2 is scope. How big or small should this thing be?
Yeah, scoping is crucial early on. Are you building a single agent system that tries to do everything? Or would it be better as a multi-agent system? Maybe one agent is responsible for just capturing raw data from various sources. A second agent analyzes that data to see if it represents a qualified lead. And a third agent specializes in generating personalized outreach emails.
Specialization again?
Exactly. And thinking about potential reusability right from the start is really important here too. Can components be reused in other automation tasks?
Makes sense. Step 3, choosing the right tech, frameworks and tools.
Right. You need the right stack to build and manage the agent's architecture. The sources mention several popular open source options. LangChain is very popular for building modular, often sequential agent workflows.
Okay.
Llama Index is apparently excellent, particularly for building the RAG components, connecting to data, and managing more event-driven agent steps. And then for more complex scenarios, especially multi-agent systems where agents need to collaborate in sophisticated ways, you have tools like LangGraph or Crew AI. These often use a graph structure to manage the flow of information and control between different agents, allowing for more complex nonlinear workflows than a simple chain.
Okay, got the framework. Step 4 is plugging it into the real world, data integration.
This is key. You need to identify every system the agent needs to talk to and build those connections. Your CRM platform, obviously. Email marketing tools, maybe. External data sources for enriching lead information like company size, industry, funding rounds. Internal databases. The agent needs reliable ways to pull data from these systems and potentially push data back.
Gotcha. Step 5 brings us back to the brain model selection. Choosing the right LLM, but maybe tailoring it.
Yeah, it's not just picking any LLM. You need to choose one or maybe several
Hmm.
that are well suited for the specific tasks the agent needs to perform. For example, an LLM optimized for summarizing long financial reports might be different from one designed for generating creative, persuasive marketing copy.
Uh-huh.
And often, for the best results in a business context, you'll want to do some fine-tuning. Taking a powerful base model and further training it on your own specific data, maybe examples of successful sales emails, your company's unique product terminology, or transcripts of good customer interactions.
Why is that fine-tuning so important?
Because it makes the agent's output much more relevant and effective in your specific domain. Imagine an agent fine-tuned on your best sales emails. It learns your company's voice, the arguments that resonate with your customers, the right level of formality for different industries.
Ah, so it doesn't just sound generic, it sounds like us.
Precisely. It could even potentially analyze a prospect's online presence, maybe their LinkedIn profile or blog posts, detect their communication style, formal, informal, technical, and then adjust its generated email to mirror that style. That level of personalization can significantly boost engagement because the outreach feels custom-made, not like a generic template blast.
That's powerful. Okay, and the final step, step 6, is absolutely critical before letting this thing loose.
Development and testing. You build the integrated solution, you put in strict guardrails, clear rules about what the agent is allowed and not allowed to do. Again, even you can draft emails but needs human approval to send, or it can update lead status but cannot delete contacts.
Yeah.
And then you test it rigorously. Hammer it with edge cases, try to trick it, make sure it fails gracefully. You absolutely have to do thorough testing before deploying an autonomous agent into a production business process.
No kidding. Okay, once it's built and tested, the research highlighted a couple of more advanced concepts for how these agents are used in sales and marketing. One was headless agents.
Yeah, headless agents. These are agents that do their work entirely behind the scenes. There's no chatbot interface for the sales team to talk to directly necessary.
So how do people interact with it?
They might not interact with it much at all. They just see the results appearing in their regular tools. Optimized lead lists automatically populated in the CRM, appointments magically appearing on their calendar, draft emails ready for review in their inbox. The agent is doing all the complex monitoring, analysis, and prep work invisibly in the background.
Okay, efficient. And the second advanced concept was about the agent getting smarter over time.
Right, learning and adaptation. Good agents aren't just static rule followers. They should proactively monitor for triggers. Maybe a news article mentions a target company just secured new funding, signaling a potential buying opportunity.
Mhm.
The agent could then proactively suggest a strategy. Hey, customer X just got funding. They probably need solution Y now. Here's a suggested outreach email focusing on how we help companies scale after investment. And crucially, they learn from feedback. By tracking metrics like email open rates, click-through rates, meeting conversion rates for the leads it prioritized or the emails it drafted, the agent can start to understand what works best and automatically refine its own lead scoring algorithms or outreach strategies over time. It gets better at its job. Okay, now, here's where things get Really interesting. And frankly, where we need to be extremely careful. When we start giving systems this kind of autonomous power to act in really high-stakes environments like cybersecurity, like critical IT operations, we absolutely must have a serious discussion about the inherent risks. The dangers get magnified when the system can make decisions and take actions without direct, moment-by-moment human control.
Right. The potential for things to go wrong is much higher. The first risk is one we've heard about with LLMs generally, but it takes on a whole new level of danger with agents.
Hallucinations.
Yeah, hallucination. The tendency for LLMs is sometimes just make stuff up, but state it with absolute confidence.
Mhm.
In a simple chatbot, that's maybe funny or annoying.
In a SysOC, an agent analyzing a potential incident might hallucinate and confidently report back, System X looks totally clean, no sign of compromise, when actually it is compromised. Or worse, it might hallucinate a solution and suggest a remediation step that's completely wrong and could actually destabilize or break a critical production system if acted upon.
Yikes. Okay, that's scary. The second big risk you flagged involved attacks on the agent, but not by hacking its code directly, more like tricking it through its inputs.
Exactly. This is called adversarial manipulation, or sometimes indirect prompt injection. Because agents rely on their tools to read data from the outside world, log files, emails, database entries, web pages.
Uh-huh.
An attacker can try to poison that input data. They could craft specific, weirdly formatted log entries or embed hidden instructions or misleading phrases within an email or a database record that the agent is expected to process.
And the goal is to fool the agent.
The goal is to hijack the agent's reasoning process. Trick it into misinterpreting a real threat as benign, maybe ignoring critical alerts, or even generating a farce report that sends the human analysts chasing ghosts. They're manipulating the agent's perception of reality through the data it trusts.
Okay, that's subtle and dangerous. And the third risk you mentioned focuses back on the human side, the danger of us trusting these things too much. You use that German term, menschliches overfitting. What does that mean here?
Yeah, menschly is overfitting. It translates roughly as human overfitting. It's the psychological risk that the human experts, the SOC analysts, the SREs, start to trust the agent blindly.
How so?
Well, if the agent handles, say, 95% of its tasks perfectly, quickly, and reliably, it's very easy for the humans working alongside it to become complacent. They stop double-checking its work as rigorously. They start just accepting its output without applying their own critical thinking,
This it's usually right.
because it's usually right. But then, on that crucial 5% of cases where the agent does hallucinate or gets tricked by an adversarial input or just misses something subtle, the human fails to catch the error because they've overfitted their trust to the machine. The agent is meant to augment human oversight, not completely replace it.
Okay, so the risks are real. Hallucinations, manipulation, over-reliance. The need for clear rules, for guardrails, is obvious. What's the fundamental balance we need to strike here? How do we get the benefits without unacceptable risk?
The core principle has to be human in the loop, but implemented rigorously, not just as a buzzword. And the absolute #1 rule, the starting point, must be autonomous agents should never have unrestricted right access power over critical production systems, especially not systems where they could shut down services, delete data, or block legitimate users without explicit human confirmation.
Okay, no handing over the keys to the kingdom. What's the practical, safest way to start deploying an agent in a high-stakes area like a SOC or SRE team?
The best practice for initial deployment is almost always read-only access, or deploy it first in a sandbox non-production environment that mirrors production,
Why read-only?
because it lets the agent run, process real data, show its reasoning, demonstrate its chain of thought, and prove its accuracy and consistency without having the ability to actually break anything. You build confidence in its analysis capabilities first before you even think about letting it make changes.
Okay, that makes sense. Prove itself first, and then for any action that does involve changing something, blocking an IP, patching a server, rolling back code, what's the rule?
The crucial rule there is require explicit, ideally multi-factor, human confirmation for all high-risk right action steps.
Mhm.
The agent can do all the work, identify the threat, figure out the root cause, even generate the exact Ansible playbook to fix it.
Uh-huh.
But a qualified human analyst must review that proposed action and give explicit approval before the agent is allowed to execute it. Block the IP, isolate the machine, shut down the service, whatever it is, a human has the final say.
So it's firmly trust but verify. How does an organization get comfortable enough to maybe grant more autonomy over time, if that's even desirable?
It has to be a very gradual, stepwise process based on proven performance. The research suggests a path like this. Start isolated, read-only or sandbox. Test it absolutely exhaustively against known scenarios and edge cases. Continuously review 100% of its outputs and decisions in the early stages.
Okay.
Then, critically, use feedback mechanisms like reinforcement learning from human feedback, or LHF, where humans explicitly correct the agent's mistakes or confirm its good decisions. This helps tune the agent's precision specifically for your operational environment. Only when the agent demonstrates consistent, reliable, trustworthy performance over a sustained period and the human team is fully confident in its capabilities and its limitations, should you even consider very gradually increasing its level of autonomy for specific, well-defined, lower-risk tasks. Trust has to be earned through rigorous documented validation. Hashtag tag outro.
So wrapping this all up, what does this really mean? We've taken a pretty deep dive, and it seems clear that AI agents are, well, kind of the next evolution in operational intelligence, maybe cognitive intelligence too.
I think that's right. They seem specifically engineered to tackle the sheer complexity and the overwhelming volume of data that's just swamping human experts right now, whether that's a SOC analyst trying to make sense of a million alerts or an SRE team racing against the clock and against sleep inertia to fix a critical outage.
Yeah, these agents feel like the direct technological answer to that dual crisis we talked about, the data flood and the expertise shortage.
Exactly. By using these architectures, the LLM brain, combined with tools, that crucial semantic memory, and especially that non-negotiable reflection loop, we can start to delegate the really high-volume, repetitive, but still cognitively demanding tasks to the machines,
Freeing up the humans.
freeing up human brain power for the stuff that really requires strategic thinking, creativity, and complex judgment.
And we saw that incredible power of specialization with the multi-agent approach, like in the narrative design example. The planner, the forge, the critic, all working together to do something, write a coherent novel that one big AI just couldn't handle alone. That really points towards a future where complex work isn't done by one giant AI, but by collaborative teams of specialized AIs.
It certainly seems that way. And of course, we also saw just how critical those guardrails are, the absolute necessity of starting with read-only access, demanding human confirmation for any potentially destructive action. The agent has to remain a powerful tool, an indispensable augmenter of human skill, not become an autonomous liability.
Which brings us to a final thought, maybe a provocation for you, the listener, to mull over. If these agent systems can coordinate really complex multi-step responses to technical disasters in real time, or even collaborate to write an entire stylistically consistent novel by dividing up the cognitive labor, well, what common high-volume managerial tasks might be next in line? Think about the tasks that involve gathering data from multiple sources, synthesizing it, ensuring consistency, and applying rules.
Like creating complex reports.
Exactly. Think about something like compiling a quarterly corporate performance report. You could easily imagine a multi-agent system. One agent pulls financial data from accounting systems, another scrapes market analysis reports, a third gathers internal operational metrics, a fourth agent writes the narrative summary, and maybe a fifth crucial critic agent constantly checks the language against legal compliance rules and brand marketing guidelines.
That kind of organized, automated intelligence for complex knowledge work.
That seems like exactly where this multi-agent, autonomous but guarded approach could strike next. Something to think about.